So hello and welcome everyone, my name is Jay Dalsaniya and in this video we are going to solve the problem of the day, that is split the array. The problem statement is very interesting and the trick on how to solve this is also very interesting. So without wasting any further time, let's try to understand what the problem statement is trying to say. So here you will be given an array of integers and the task is to count the number of ways to split the given array elements into two non-empty subsets such that the XOR of elements of each group is equal. Right, so you are supposed to find out what are the different ways to split the given array such that there will be two groups and the XOR of both the groups are equal. So each element should be belonging to exactly one subset. So there should not be any element that will be appearing on both the groups. And there is a note that the answer could be very large, so you are supposed to apply 10 to the power 9 plus 7 and the subsets with the same element but derived from different indices are different. Means the repeating elements, if they are there and if you create different groups, then they are considered to be different subsets. Okay, let's see the first example. In the first example we have 1, 2 and 3. So let's try to understand with the help of the first example. So let's say n equals to 3 and the array elements that you have is equal to 1, 2 and 3. So here I am supposed to divide this given array into two groups. So let's say in the first group, if I keep 1 and in the second group I keep 2 and 3, what will be the XOR of this group? So we know that the binary representation of 2 is something like, let's say this is 1, 2, 4 and 8. So it is somewhat around 1, 0. Right, and this will be 0, 0, and the binary representation of 3 comes out to be 1, 1, and this will be 0, 0, and for 1 we know that 1 is represented as 0, 0, 0 and 1. So if we do XOR of 2 and 3, what do we get? So this set bits, both of them are set, so this will be 0 and this will be 1. So we get 1 as the XOR and this group as XOR of 1. So this is one of the way to partition. So there will be other groups also possible. So I'll write down the groups over here. So we have 1 and 2, 3 is one of the group. So I can keep, let's keep this 2 on the first group. So I'll have 1, 2 and this will be 3. So let's see the XOR of 1 and 2. What do we get as the XOR of 1 and 2? So here I'll be getting 0 and 1, so this will be around 1, 1 and this is 3. So we get 3 over here, 3 over here. So I'll be getting 1, 2 as the first group and second group will contain only single element, that is 3. Now again what I will do, let's keep 3 with 1 and what I will do, I'll keep this 2 in the second group. So I'll have 1, 3 over here. So this will be having XOR 3 and here let's take 3 and 1. So let's say 3 is 1, 1. And 1 is 0, 1. So here what I will be having, I will be having 0 and this will be 1. So I get 2 as the XOR. So I'll be getting the XOR is same. So the group comes out to be 1, 3 and 2. So these are the three different ways to basically divide the given array into two different groups, and both the groups are non-empty groups. Okay, so you are supposed to write down what are the different ways. Here it came out to be there are three different ways. So the output for the given test case comes out to be 3. So I hope you understood what the problem statement is actually trying to say. Okay, so now let's brainstorm a little bit on how we can solve this. So here the problem is saying that, I'll write down the approach here, that you are supposed to find out the number of ways to split the array. Okay, so first of all we need to identify whether an answer is possible for a given group or not. So they are saying that XOR of first group is, let's say this is the XOR and I will write down X1. This will be the XOR of the first group and the second group will be having XOR as, let's say, X2. And they are saying that this X1 should be equal to X2. Okay, so that means X1 and X2 both are same. So I can write down as X1 for G2 as well. So one thing we know that if we have the XOR of G1 and G2, then does it mean that if I do the XOR of the group G1 with G2, so this will be XOR of all the elements, right? A1, A2, A3 till AN, right? So if XOR of, if G1 is X1, that means XOR, and G2 is also X1. So if you do XOR of the same element with itself, what do you get? You will be getting 0. So does this mean that the XOR of all the elements should be 0 in order to get the two groups having same XOR? Right? We know that if we do XOR of 9 with 9, we'll be getting 0. XOR of 3 with 3, we'll be getting 0. XOR of A with A, we will be getting 0. So first of all, we need to identify that whether answer is possible or not. Given the condition that the XOR of all the elements of the given array should be 0, then and only then you can partition the given array into two different groups. So first thing, you should verify whether XOR of all the element is 0 or not. If it is 0, then only then answer is possible. Now how many groups are possible? So first of all, let's try to understand what are the different ways of creating the group. Or here it has been mentioned that you are supposed to create two different non-overlapping subset, or let's say two different subsets, right? Two subsets we have to create for the given array. Now for a given array of size n, what are the number of ways to create all the subsets? To create all the subsets, how many subsets do we get? We get 2 to the power n subsets, right? So does this mean that we can have on the one side in G1, we can have 2 to the power n different groups that we can create, 2 to the power n. So what about G2 in this case? So here for this G1 we have 2 to the power n. So I have listed down all the subset in the group G1. Okay. So for any group which I have created, I'll be having only one possibility. Let's say if I have 1, 2 and 3 and here if I create a group G1 that contains 1 and 2, then there is only one possibility of creating G2, right? Because G2 will be the rest of the remaining elements of the given array, right? So we are supposed to find out that how many different ways we can create G1. So we can create 2 to the power n number of different subsets. Okay, fine. So here in this G1, if I write down all the subsets, so I'll be having, for example, 1, 2, then I'll be having 1, then I'll be having 2, then I'll be having 3. So if this is my G1 and if I want to find out the G2 for the corresponding G1, then for 1, 2 being the G1, group 1, what will be the G2? G2 will be 3. Similarly, in G1, if I have only single element that is 3, then I'll be having 1, 2 over here, right? So I'll be having 1, 2. So here group G1 and G2, this both the groups are same. So total number of ways to split the array is not directly 2 to the power n, because here you can see that for every group you will be having some repeated values over here, right? So this is a repeating pair, this and this, pair 1 and pair 2, both of them are same pair, right? So here if you say that the answer is 2 to the power n, then it is completely wrong. So here you can see that for every group G1, there will be G2 present as G1. So can I say that the answer will be around 2 to the power n divided by 2, right? But still, in this 2 to the power n, we will be having empty subsets as well, right? Total number of ways to create subset is equal to 2 to the power n, and 2 to the power n includes an empty subset. So here in G1, there will be one empty subset. Then you will be having all the elements as G2, and in G1 if you have all the elements, then in G2 you will be having an empty subset. So you are supposed to basically from 2 to the power n, you are supposed to basically remove this two empty subsets, right? And we know that there will be repetitions, so I'll be dividing this by 2. So overall, what can I say about the answer? So the answer will be around 2 to the power n and divided by 2 minus 2 divided by 2. So this will be around 2 to the power n minus 1, and this will be around minus 1. So the total number of ways to split the given array, if the answer is possible, is around 2 power n minus 1 minus 1. So first of all, verify. If I just summarize the algorithm. So the algorithm says, first of all, answer is only possible when XOR of array equals to 0. And if the answer is possible, then answer is always 2 power n minus 1. And that's why they are saying that you are supposed to apply modulo 10 to the power 9 plus 7, because this exponential value, that is 2 power n, can be very large, right? So here you are supposed to apply modular exponentiation in order to get the value of 2 power n minus 1, and keep on applying the modulo with 10 to the power 9 plus 7. So now let's see how we can implement the same algorithm in Java. You can take the reference of this algorithm and implement using any programming language. So here I have implemented this entire code into so-called Java. So here is our count group function. I have created this mod integer 10 to the power 9 plus 7. The length is taken as n, and XOR of all the element is given as 0. So I'll be iterating over all the element and verifying whether XOR of all the element is 0 or not. If it is 0, then and only then I'll be creating I'll be calling the power function to find out the value of 2 power n minus 1 minus 1. That is going to be the answer. Okay. So here, if the answer is not possible, then I'll be returning 0. If XOR isn't 0, then answer is not possible. There are 0 ways to split the given array. Now, if answer is possible, I'm writing down this modulo exponentiation function. Okay, so power function. And if you don't know how to find out modular exponentiation, I highly recommend that trick is very important and it will be used highly in medium to hard level of questions. So learn about how to find modular exponentiation. Okay, and if answer is less than 0, then I have added mod to the answer, that the answer is always non-negative, because number of ways are non-negative always, right? And then I'll be returning the value of answer. So now let's try to click on the submit button and see whether this solution gets accepted or not. So we can see that the problem has been successfully submitted, and hooray, I have won this geek bit for today's problem of the day. So if we talk about the time complexity is around order of n. Okay, and if we talk about the time complexity to find out 2 power n minus 1, it will be around log n. Okay, because of this modular exponentiation. So overall, I can say the time complexity is around order of n, and the space is constant, order of 1. So that was it for in this video. I hope you really enjoyed this solution, and if you really enjoyed this solution, then do hit the like button and share down your approach in the comment section below. So that was it for in this video. So I'll be seeing you in the next video. Till then, keep coding, and thank you everyone for watching.